All right, so as we stated earlier, we're going to focus on energy. And really, we're just going to brush the surface and think about what's related to chemistry and chemists as a whole. And so if you want kind of a deeper discussion on energy, you need to go ahead and check out your physics course. They've got a lot of good stuff there. But we're going to generally just define energy as the capacity to do work. And there's kind of two main types of energy. We have the potential energy, which is stored energy. You know, if you put a book on a higher shelf, it now has more potential energy than a book on a lower shelf because it can fall down and do some kind of work as it's falling down. And then the other is the kinetic energy, which is the energy due to motion. So, for example, a car traveling at 100 miles an hour has more energy than a car traveling at 5 miles an hour. So, in terms of chemistry, we're going to focus on both of these. In thermal energy, or my bad, with kinetic energy, what we're going to be focused on is thermal energy. And so, thermal energy is kind of how hot something is, and that has to do with the random motion of atoms slash molecules. And that's actually where we'll start off. And then later on, we'll talk about potential energy. For chemistry, our potential energy is stored in bonds. So for example, we've seen combustion reactions, C3H8, in this case, propane. So that's what you kind of grill with. I'm not going to balance it, but it forms carbon dioxide and water. And then it also provides a bunch of energy in the form of heat, right? So the energy that's coming out of here is coming from the formation of bonds. And so we'll take a look at that throughout the second part of this chapter. So one thing we discussed with matter is we said that matter cannot be created nor destroyed. It can only be kind of moved around and transferred. And the same thing is true for energy. Right, so the law of conservation of energy. So energy cannot be created, destroyed, only transferred. And so whenever we take a look at a system, it can gain or lose energy, but it has to come from something else acting on it. So a system can gain energy by being heated or having work done on it. And it can lose energy by losing heat, giving it to something else, or by doing work. For us, we're going to focus primarily on the heat part, right? Losing heat or being heated, and not so much the doing work. If you want to check out your textbook, there are some examples there where you can talk about energy in terms of doing work. But for us, it's going to be mostly about heat. So energy comes with its own units. The main SI unit for energy is the joule, which gets a capital J. 1 joule is equal to 1 kilogram meter squared over second squared. Don't worry about that. It's a physics thing. If you're interested in units and derived units and that kind of stuff, it's pretty interesting. Feel free to chat about me with it, but it's not a focus of the class. 4.184 joules is equal to 1 calorie, right? So calorie is probably something that you've more so heard of, right? You see it on the food wrappers and whatnot, but they're essentially, just units of energy, just like, mile and meter are unit of length. These are just units of energy. The funny thing about a calorie is that 1 calorie with a capital C is equal to 1,000 calories with a lowercase c. And the calories on your food and stuff like that are these capital C calories. So I don't know whose bright idea that was, but it is what it is. Another unit of energy that you're probably familiar with is a kilowatt hour. right? That's how we kind of measure how much energy our houses use, and your electricity bill, if you pay that. That's equal to 3.60 times 10 to the 6 joules. So you can see it's worth quite a few joules. And then, of course, 1 kilojoule is equal to 1,000 joules. We're pretty much only going to use joules as our unit of energy. So you don't have to worry about too much, but I just wanted you to be aware of them.